Good morning, good afternoon, and good evening. Welcome to our second Hangout event. Today, we're honored to have Professor Yossi Sheffi here. Thank you for accepting the invitation, Professor.
Sure.
Professor Yossi Sheffi is a Elisha Gray Professor of Engineering Systems at MIT. He's also a professor at the MIT Civil and Environmental Engineering Department. He is also the director of the MIT Center of Transportation and Logistics. Professor Yossi Sheffi is an expert in system optimization, risk analysis, and supply chain management. He's also the author of books such as Logistic Clusters, The Resilient Enterprise, and The Power of Resilience. It's a privilege to have you here. So the topic of today is how 3D printing is affecting or will affect or is affecting supply chains, and particularly the role of procurement. Okay, so the agenda for this session is going to be the follow. I'm going to start asking some general questions about the topic to Professor Sheffi. Then you will have some time to ask a couple of questions that we already shared with you guys. Then we will come back and we will elaborate them based on the answers that you might have. Okay, so let's get started. To make sure that everybody in the audience is in the same page, Professor, let me ask you the following question. So what is 3D printing?
3D printing is also known as additive printing. It's a process by which three-dimensional items can be built layer by layer. So think about a printer. A printer can put layers of ink on paper. Here we are putting layers of material upon other layers of material, driven by a digital plane, so driven by a computer, and there's a nozzle that sprays this material. It can be a polymer, can be metal, can be lots of other materials, even concrete. Can be done layer on thin layer until you build a complete structure. So that's basically and actually the 3D printing is not one technology, it's a family of technologies, because the material that you work with matters. So if you work with metal, in many cases, you work with lasers because it has to be, that's how it bonds to the layer below it. If you work with polymer, you can simply heat it. So it all depends on the type of material and type of process, but the whole family of processes of building three-dimensional projects, three-dimensional items.
Okay, thank you. So I've noticed that some authors, including you, use the terms 3D printing and additive manufacturing interchangeably. Are we talking about the same technology? Are these different technologies but similar, or are they completely different?
These are synonyms. Both synonyms are referring to a whole group of technologies that the commonality is they are building thin layers by thin layers, three-dimensional objects.
Okay, excellent. So advocates of 3D printing argue that this technology enables firms to economically build custom products in small quantities. But what are other advantages of 3D printing compared to traditional manufacturing processes such as injection molding and cutting-based machinery?
Well, first of all, have to think about even the big supporters of 3D printing or the promoter of 3D printing don't expect it to completely replace mass manufacturing. Any type of mass manufacturing. It's simply too efficient. However, given the fact that they are built one at a time, it means that you can first of all customize very easily. So even when 3D printing is done on a production line, since they're basically done one at a complete item at a time, you can make them different depending on customer requirements. You can also make them, one of the big applications of 3D printing is for prosthesis, can be for artificial teeth. There you can take exact measurements and create one-off for every application. Give you another example also in the healthcare. In some hospitals in the US, when a person goes to have a hip replacement, it's basically the ball in the hip that has to be replaced. Up to now, surgeon used to open the person up and then have several of these hip balls and try to match the one that is closest to what the original was. New process is not taking place when the patient goes under MRI, and through this three-dimensional looking at the person, they get the exact measurement of the current hip, and then it's being manufactured just for that person, just for that person, and it's much better fit to the hip. So first of all, it's easy to make one-offs. Finally, the other use of making one-off, in addition to healthcare and customization, is for engineering prototypes. Engineering processes are much faster when you can create a full prototype rather than just on the screen. You can create a full three-dimensional object and see what works, what doesn't work, and then within a day build another one and another one and another one. So the whole process of building prototype and testing prototype is much faster. So engineering process, and it speeds up the whole design and engineering process. Another element is that it has huge impact, or will have, and still has, already has huge impact on supply chains. In the sense that if you need, for example, rather than talk in general, I'll give you an example. General Electric manufacture nozzles for their new jet engine, use their 3D printing. Each nozzle used to be made out of 19 parts and made by 19 suppliers, and then machined and assembled by GE at their factory. Instead of these 19 suppliers and 19 parts, there's just one part, the titanium, which is the raw material, and it goes into the printer, and the part is completely built out of titanium. So it reduces the number of suppliers. It also reduces the supply chain tiers, because you get, usually titanium will go to sub-supplier, will go to supplier, another supplier will get to the OEM, to the retailer, to customer. Here you can go directly from raw material, either to OEM, if you talk about the industrial production, or long-term from now, directly to the consumer, if consumers will have their own printer. So all of this will have significant impact on supply chain. By the way, there's also one other advantage of, two more advantages I want to mention of additive or 3D printing. You can make structures that are much more complex than what you could make with any other process, any other industrial process, because you build it from scratch and you can build all the intricacy that you can dream about. So in that sense, complexity is basically free. Another thing that you get is that there's very little waste, because you build it up rather than extract, rather than take material away. You are building up the item, so it has very little waste. Maybe another, as I'm thinking about it, think about the inventory level for parts. When you have parts, let's say, companies like Caterpillar have their equipment running for 50, 60, 70 years, and they have to keep parts for these old tractors from 1940s, 1950s. They're very expensive. Instead, for parts that you need very few of, you can just make them on demand. So you don't need to keep all the inventory on hand, and just keep parts on demand. Anyway, these are some of the the pluses of dealing with 3D printing. Now, the technology is not perfect yet. Of course, we'll have there are downside technology, and sometimes the item that comes out of the 3D printing needs a lot of polishing and a lot of handling, but these machines are getting better and better. So it has a lot of implication.
Okay, thank you. So given that with this technology, with the 3D printing, so economies of scale don't apply in this case. Making a single item will cost similarly to having a
mass production.
Mass production, right? So what type of products are suitable of being a manufacturer using this technology?
Well, we talked about the type of products that you don't create in a large number. Now, this is a general statement. It's not always true. The example that I gave for GE, they are making 40,000 nozzles a year. So, but they're not making millions. They're making 40,000 a year. So if you need to make millions of something, it's not clear that it makes any sense. You also want something that are very intricate. You can build things that are much more intricate and lighter. The nozzles that GE is building will help the engine, the jet engine that they are put into, to be lighter and to be more fuel efficient, because it's the more precise dimensions of the item. As I said, they work very well for medical applications, because then you have to specify to the person. You can specify what the prosthesis or the tooth or whatever to the person, and you get it's a lot less work, and you get something that fits much better. It's a much better outcome. Before we leave this subject, however, I also want to talk about some of the downsides of 3D manufacturing or additive manufacturing. First of all, now it will be much harder to keep intellectual property, because it used to be that we have in the company, we have plans and engineering drawings kept in a safe. Now it's online. Now it's all in a computer, so IP can be stolen. And there's the issue of cybersecurity. I'm just listening to the Comey testimony. If people can get into the Democratic National Committee and steal stuff, why can't they get into your printer and do all kind of crazy stuff with your print, all kind of crazy stuff? In addition, you can manufacture illicit product. Why can't you manufacture guns? Why can't you manufacture drugs? So why can't you? You can. And furthermore, right now, we have online instruction on how to build bombs, for example. A lot of the terrorists are taking their, especially the homegrown terrorists, are taking the instructions from the internet. Well, there'll be instructions on how to use this and that printer, to how to build guns and how to build illicit drugs and whatever else you want to. So there's this downside to every technology, just like we talk about, the internet. It's a great technology, it helps a lot. It has a downside. So just want to point out that a lot of regulatory work still need to be done in order to make sure that we get the upside of technology and not the downside.
Okay. So, Professor, you mentioned some of the implication of 3D printing to supply chains. So you mentioned, for example, the reduced inventory levels, reduce the number of base of suppliers, and I will also like to add that the localizing manufacturer, because in this case the 3D printer, or in this case the manufacturing facility needs to be closer to the final consumer. Are there any effects on the supply chain? How will 3D printing will affect supply chains?
Well, we just talked about it. The issue of localization, the dream of the developers is that you'll have your 3D printer at home, and when you want the next coffee maker, you just make it. That's not going to happen, in my estimation, anytime in the next several decades. What we may have is making production, by and large, closer to, say, urban areas. Because production will still be, when you start thinking about heating metals and getting them, cementing them, there's a lot of material, a lot of stuff that you don't want in your house. But you can have it in a factory. So maybe we'll have smaller factories that are distributed, possibly. But this is where, when you talk about localization, that's where I see this going, that we will have the production close to consumption, but not at the home. I don't see it going to the home anytime soon.
Okay, thank you. And also, I would like to hear about some implications that this technology will have to engineering in general.
Well, we talk about engineering. Some of the issues that I mentioned before are the fact that you can make products that are a lot more complex. So the slogan is complexity is free. Engineering, usually, good engineers, good design engineers understand the constraint of manufacturing. So they are not going to design something that then manufacturing cannot make. Here, you remove this constraint, and almost anything can be made. So the question is, so we're going to make parts that are more accurate, more intricate, more fit to purpose. That's one impact on engineering. The other is what I mentioned before, the speeding up of the engineering process, because you can make prototypes. So you can run it a lot faster. You can make some design and test it and see how it works, and then put it to strength and strain, and then bend it, and then heat it and cool it, and try. You're working with a real item, not with a 3D image on the screen. So the process of basically every engineering new part is a trial and error process at the end. So here you can do it much faster with real three-dimensional objects of the final product. So it simply goes a lot faster.
Okay, so we have some time to ask you some questions that the students have posted in the chat. So we have one from Paramayer, and she's asking how much has 3D printing been used in medical field, substituting resin with stem cells?
Substituting what?
Resin with the stem cells.
I don't know about resin stem cell. It is used, as I say, in the medical field. Most of the application that I'm familiar with has to do with prosthesis, making artificial parts, whether artificial limbs, artificial teeth, and people are starting to build more, the dream is you can build liver parts, you can build hearts. It's not happening yet, but that's there are people working on it, but I'm not familiar with stem cell.
Okay, so another question from Mustafa Hafez. It is known that 3D printing can be used for complicated cross sections.
Yes.
How useful it is for mass production?
It is at this stage, and for foreseeable future, I don't see 3D printing used for mass production. Part of the problem is that mass production are so efficient. And today, 3D printing is really slow. I mean, it takes this nozzle that I mentioned, it can make a day to make one, or hours to make one. And so right now, when it's a relatively, when you make many of them, you simply have many printers right next to each other. And that's how GE is doing it. GE and Siemens and others who are getting into 3D printing. So at this point, I think that every new technology finds its niche after a while. And I don't see it replace, even if we talk about e-commerce. You think there'll be a time there'll be no stores at all? No, there'll be stores. Even now, there are stores that are doing okay. But e-commerce, is getting its part. When you think about RFID, when you think about every new technology, end up serving part of the market. It's exactly the same. 3D printing, even when it gets a lot better than today, I don't see it replacing mass manufacturing. It will be used in part of the market, part when you need intricacy, when you need the, customization. That's where, and the numbers are not high. That's where you start seeing 3D printing more and more. But I don't see it replacing mass production.
Okay, so we have another question from Nuria. She mentioned that she works for the aerospace industry, Airbus particularly, and our products are certified by the aerospace agencies. How could we add those 3D parts in our planes? Should the process be certified, the parts both?
Yes. In fact, interestingly, GE is making jet engine parts. Though these parts are certified, they have to be certified. It's not only in airplanes, in automobiles, in a lot of consumer products have to be certified. It's interesting that GE would go to the process of GE or Siemens with the turbine and stuff. Lots of companies who are getting seriously into 3D printing are going through the certification process. It will be interesting to see what happens to automobiles, because as I mentioned, the numbers in jet engine and in the even airplanes, you're talking about hundreds or thousands or tens of thousands. When you start talking about cars, you're talking about millions. And will there be carburetors that are being made with 3D printing? Possibly. You start with high-end car, and if the process can get significantly faster, it will start finding its way to mass-marketed cars, because the carburetors can be made much better. They can be, they can make sure that the burning of the gas is much more precise, and the amount of gas that gets into the piston is much more precise than it is today. So and also the parts will be lighter, less waste in making them. So there's room to think about making them, but it will be a while, because you cannot make them at this point. Making the millions per year is really out of the question.
Okay, so we have another question from Mustafa, and he's asking if you can kindly elaborate on the reasons why 3D printing is cost effective, and how close can it get to mass production?
Well, the question is, what do you mean by cost effective? What do you include in the cost? If you include the time to make the part, it's not even close. So, as I said, I don't believe it will replace mass production. For parts that you need to make in large number and identical parts, there's no reason to use 3D printing. You won't use 3D printing if some of the characteristics of 3D printing are important to you. For example, if every part needs to be a little different, needs to be customized, then you want to make them one at a time. If there's special intricacy that simply you cannot build a part, or it's much more complicated to build a part using traditional methods, then you might want to think about 3D printing. But if you have to make, 1 million, panels of, a fender or a fender of a car, and you sell them in the millions, I don't see it anytime soon. Maybe never getting to be done through 3D printing. So I would the cost differential is still significant for when the number is large. But there may be, as I said, other considerations that are more important than the cost per part. It's the ability to customize, the ability to fit, the intricacy of the part. That's where 3D printing today counts, and it will take more. It will take more and more place, and more parts will be made with 3D printing. But it will be. I don't see it replacing mass manufacturing in the next 2-3 decades.
So at the end, economies of scale, economies of one will coexist.
Yes, that's it. Yeah. It's economies of one, even economies of thousands, but not economies of millions. Additive manufacturing today, the industry is growing. It's growing by 26% in 2016. It's now over a $5 billion industry. And it used to be just a hobby and prototype, but now, and we mentioned GE, it acquired 2 companies in 2016 and $1.5 billion. Siemens expects when they get to full use of mass production for the part, that when they get the full use of additive manufacturing, for the parts that are manufactured additively, they expect 30% cut in greenhouse gases. They expect over 60% cut in resources used. And mostly, very importantly, shrinking the time to market because of the design and engineering cycle. They expect to shrink the time to market by 75 or 80%.
Okay, so to close this section, let me ask you the final question. Do 3D printers allow end product creation with multiple raw materials?
Yes. 3D printing, think about a regular jet printer that you can do in multiple colors. It's the same type of idea. Now, it's obviously more complex because the question is how do the layers bond to each other? And it's not clear that it makes sense to bond certain layers. So it may be that we'll end up, if parts are made of, if an item are made of significantly different types of material, and wood and metal, that you do the metal part separately and the wood part separately, and you have to put them together. But several types of metals can be done on the same 3D printing.
Excellent. So it's time for the breakout session. So please join the breakout rooms, and we'll have 2 questions for you guys. So the first one is, what are the challenges or the barriers that you foresee your local companies will face implementing 3D printing? Please come out with 3 to 4 challenge barriers. And the second one is, when do you see this technology happening in your local companies or your local environment? Okay, so we'll have 15 minutes and we'll be back soon.